Today, I'll be talking about the Fibonacci sequence. If you like this video, make sure to hit that like and subscribe button. Well, what is the Fibonacci sequence? It's a sequence of numbers that starts with 0 and 1, where if you add these two numbers together, we will get, in this case, 1. But this continues on, so if we add 1 and 1 together, we get 2, 1 and 2, we get 3, 2 and 3, we get 5, and so on and so forth. This sort of relates to the golden ratio, but it really shows up best when we consider the sort of, I guess, drawed approach. So if we have two cubes, or two squares of, say, size 1 and 1, well, if we draw another square, well, this would be size 2, because 1 plus 1 is 2. If we draw another square off the side of this one would be size 3, right? 2 plus 1 is 3. Then again, 3 plus 2 is 5. Then again, 2 plus 1 is 3, plus 5 is 8. And you can continue on forever and ever, and you'll get this large sort of representation. But this is kind of where it comes from, and we can kind of draw a spiral right? We have this sort of spiral. You may have seen a spiral like this before. It's this Fibonacci sequence and golden spiral, as this is called, is found all throughout nature. This kind of looks like a snail shell, almost, a little swirl like this. This occurs because of the relation between the Fibonacci sequence and the golden ratio. The golden ratio is a ratio that is defined by this sort of, we'll use the squares. We have this length A, and we have this length B. My B looks weird. Okay. A and B. Now, the golden ratio states A plus B over A is equal to A over B, which we denote as phi. This is just a Greek letter phi. It's just a representation. And so this is some sort of golden ratio where the sum of these two, so A plus B divided by A, is equivalent to just A divided by B. Now, this might not make sense since it is a little complicated and there's a lot of proofs that I might be, jumping through. But what does this get us? Well, going back to this formula, A plus B over A equals A over B equals phi. If we set B equal to 1, just arbitrarily set B equal to 1, well, if we plug that in here, we're going to get A over 1 equals phi, which means that A equals phi. If we then plug this into here, we are going to get phi plus 1 over phi is equal to phi. Now, how does this help? Well, we can rearrange this by multiplying phi to both sides. We're going to get phi plus 1 equals phi squared. Then we can rearrange again. We get phi squared minus phi minus 1 equals 0. And this is now a quadratic formula that we can solve for because we have phi squared, phi, we have our A, our B, and our C equal to 0. Now plugging this into the quadratic formula, I will spare us the time. We're going to get phi equals 1 plus or minus the square root of 5 over 2. And this is our solution. So this is one of our golden ratios when b equals 1. Now, the reason that this follows the Fibonacci sequence through a couple of proofs that I won't bore you with, we can figure out that this golden ratio number, this phi value, actually follows the pattern of the Fibonacci numbers. So this basically is saying the next number in the sequence is equal to the previous two numbers in the sequence. So if we're doing Fibonacci numbers, in this case, fn minus 2 would be 0, fn minus 1 would be 1, and equals 1. And we do it again, 1 plus 1 equals 2, and you can kind of see how it recurs in this way. It's a little different because we don't just have 1 and 1, we have whatever the heck this is. But yeah, so it follows the Fibonacci sequence. These golden ratios follow the Fibonacci sequence for all values of the golden ratio. And that's why it occurs in nature, because it's kind of a optimal ratio for things to be in. Alright, thank you so much for watching. If you enjoyed this video, make sure to hit that like and subscribe button, and leave a comment below of what topic you'd like to see next. This is Dylan signing off. Hope you have a good day, and see you in the next one.